Okay, good morning, students. Today we are going to discuss about some case studies of Unit 1, and we have seen some different topics in Unit 1, and we have discussed some few case studies also. So we need to discuss few more case studies on this each topic. Okay, so from this we can able to understand how each and every topic has a different case studies. Okay, then let's get started. Okay, we'll start this class now. The first one, case studies in process safety. Okay, overview of process safety. So process safety prevents fires, explosions and toxic releases by ensuring the integrity of industrial processes. Yes, we have already discussed about it. So process safety prevents explosions, fires, toxic releases by ensuring the integrity of industrial processes. Right? This we know already. Now we are going to discuss a case study on overview of process safety. So we will take Chevron Richmond Refinery Fire 2012. So this incident involved a pipe rupture that led to a vapor cloud release and subsequent fire. This incident involved a pipe rupture that led to a vapor cloud release and subsequent fire. So the failure was a result of aging infrastructure and corrosion. So aging infrastructure and corrosion. So causes of the incident is because corrosion due to prolonged exposure to high temperature sulfur compounds. Failure to replace old and deteriorating infrastructure, which increase the risk of failure. Weak process hazard analysis, that is PHA, meaning the company did not adequately assess or manage the risk of pipeline failures. Pipeline failures. So what are the lessons we learned from this? So regular inspection and maintenance of process equipment to detect and prevent failures. Improved corrosion management, that programs to mitigate degradation from sulfur exposures. Stronger process hazard analysis, right, PHA, to identify potential risk from failures, right. So what is the significance of this case study? So this incident highlights the importance of proactive safety measures, proper risk assessment and infrastructure maintenance in process industries. So company must adopt preventive maintenance, corrosion resistance materials and rigorous safety analysis, right, rigorous safety analysis. Okay, so what is the significance of the case study? The incident highlights the importance of proactive safety measures, proper risk assessment and infrastructure maintenance in process industries. Companies must adopt preventive maintenance, corrosion resistant materials and rigorous safety analysis to avoid similar disasters, right? Okay, so from this we understood that, so any failures, maybe the pipe rupture, this pipe rupture leads to releasing of vapor cloud that ignited, right, causing a massive fire. So this process safety, understanding the process safety mainly focuses on preventing catastrophic industrial incidents such as fires, explosions and toxic releases. Toxic releases. So this Chevron Richmond Refinery Fire 2012 incident happened on August 6, 2012 at the Chevron Richmond Refinery in California. A carbon steel pipe in a crude oil processing unit ruptured. So a carbon steel pipe in a crude oil processing unit is ruptured. So this caused hydrocarbon vapor to be released, which ignited and resulted in a massive fire. See, Over 15,000 people sought medical treatment due to exposure to toxic smoke. Because the fire lasted for several hours, producing a thick smoke cloud that impacted the surrounding community. Okay. So, what are the key technical issues behind the incident? The failed pipe had been exposed to high temperature sulfur compounds, leading to sulfidation corrosion over time. So, Chevron did not replace the aging pipe even though previous inspection had shown significant corrosion. So, the company's process had a hazard analysis. Companies process hazard analysis PHA failed to identify risk of corrosion failure, meaning no preventive actions are taken. No preventive actions were taken before the rupture occurred. Before the rupture occurred. Okay. So we will see next case study. So importance of process safety in industrial operations. We will take one case study. Pasadena Phillips 66 explosion. See, these case studies are very new to us because I want you to understand these case studies because we are less aware of these case studies. Yes, but in our process safety management, we are discussing about all these case studies which really related to us. I mean, which really related to our subject. Okay, fine. So, a strong process safety framework minimizes industrial risk, environmental impact, and financial losses. So, this incident, Pasadena Phillips 66 explosion 1989, has happened on October 23, 1989. Location is Pasadena, Texas. So Phillips 66 petrochemical complex. Phillips 66 petrochemical complex. So what happened actually? What is the incident happened actually? So a massive reactor explosion occurred due to a valve failure during maintenance. A massive reactor explosion occurred due to a valve failure during maintenance. So this explosion killed 23 workers and injured more than 130 others. So the blast was so powerful that destroyed parts of the plant and caused extensive damage to nearby areas. Okay, so we are discussing the case studies related to our subject, whatever we are studying. Okay, this semester. Fine. So what is the cause of the explosion? Lockout, lockout, tag out. So we call this as LOTO. That is lockout, tag out. So it is a safety procedure used to prevent accidental mission startup during maintenance. During maintenance. So in this case, workers failed to isolate the reactor properly before conducting maintenance. Workers failed to isolate the reactor properly before conducting maintenance. So this led to an uncontrolled release of highly flammable chemicals, resulting in the explosion. Right? So over pressurization of the reactor. So the reactor was not depressurized before maintenance. Due to an operational error, pressure continued to build up inside the reactor, leading to a catastrophic failure. So what is the lessons we have learned? A strict adherence to lockout, tagout procedures. So all industries handling hazardous metal must follow LOTO procedures before conducting maintenance. Equipment should be fully de-energized and are isolated before maintenance work begins. Okay, right. Equipment should be fully de-energized, okay, and isolated before maintenance work begins. Okay. So what is the implementation of advanced process control system we can go for? Okay. So modern process control system monitor reactor conditions in real time and automatically shut down operations if pressure levels become unsafe. Digital safety interlocks should be used to prevent over pressurization, right? So what is the conclusion we can make from out of this? So the Pasadena Phillips 66 explosion was a devastating industrial disaster caused by poor safety practices and lack of process control. So, okay. So always follow lockout tagout protocols before maintenance. Install advanced process control systems. Train workers regularly. Train workers regularly. So next we are moving to next case study, that is process safety leadership case study. So we have DuPont law, Pote toxic gas release. So a strong leadership commitment ensures the integration of process safety into business operations. A strong leadership commitment ensures the integration of process safety into business operations. So leadership is very important. So we are going to move to the case study, that is DuPont law, Pote toxic gas release 2014. So actually it has happened exactly on November 15, 2014. Location is DuPont chemical plant, La Porte, Texas. Okay. So what happened? Incident, what happened? A toxic gas leak occurred due to a failure in the methyl mercaptan storage system. A methyl mercaptan storage system. The leaked gas spread into the buildings, leading to 4 worker fatalities. The plant lacked proper emergency response measures, leading to delayed evacuation. So, lacking of proper emergency response measures leading to delayed evacuations. What are the causes of the toxic gas release? A poor process safety leadership. So management failed to implement strong safety measures despite previous warnings. So there was a lack of oversight in maintenance and safety audits. So employees were not adequately trained to handle toxic gas releases, right? So inadequate hazard recognition. Workers were unaware of the risk associated with the methyl mercaptan leaks. The facility did not have a proper gas detection system to alert employees in time. So safety protocols were outdated, right? Are insufficient for handling such leaks. So insufficient emergency planning. There's lack of clear evacuation procedures led to worker fatalities. The plant's emergency response team was unprepared for such a toxic gas leak. There was no proper communication between different safety departments. So what are the lessons we learn from this? Leadership must prioritize safety culture over production targets. So process safety should never be compromised for business goals. Management must enforce strict safety protocols and regularly audit safety systems. Continuous review of process safety systems. Safety systems should be regularly evaluated and updated. Gas detection and alarm system must be installed and tested periodically. Workers should be trained to recognize and respond to hazards, right? And improve hazard identification and risk communications, right? Employees should be educated on potential workplace hazards. Companies must establish clear safety communication channels. So emergency drills should be conducted frequently to ensure quick response during incidents, right? So the DuPont La Porte toxic gas release 2014, so disaster highlights the danger of poor safety leadership and the need for strong risk management practices. Okay. So next we are moving to next one, that is organizational learning and process safety. So we are discussing for each topic one case study. Please remember. So we are taking the syllabus for first unit. Okay. And in that syllabus we are discussing for each topic one case study. Okay, now we are going to discuss about organizational learning and process safety. So each topic in the syllabus we are discussing one case study. Okay. So first one, so okay, fourth one, organizational learning and process industry safety. Industries must apply lessons from past incidents to improve safety, right? So this incident happened, Seveso chemical disaster 1976. Actually, it is exactly happened on July 10th, 1976. Location Seveso, Italy. What happened? A runaway chemical reaction at the ICMESA plant led to the release of a dioxin cloud. Dioxin cloud, right? So a runaway chemical reaction from the plant led to the release of a dioxin cloud. So the highly toxic dioxin spread over several towns, contaminating soil, animals, and people. Thousands of people were exposed, leading to long-term health effects, including skin disease and cancer risk. Right? What are the causes of the disaster? Poor emergency response planning. The company failed to have a structured emergency plan in case of chemical leaks. Local authorities were not informed immediately, delaying evacuation efforts. And lack of secondary containment. Yes, the plant had no containment system to prevent the dioxin from escaping, no physical barriers existing to trap or neutralize the toxic gas, no early warning systems, no gas detection systems were in place to alert workers or residents. The accident was only noticed after people experienced health effects. So, what are the lessons learned? Development of the Seveso Directive for Chemical Safety in Europe. So, the Seveso Directive 1982 was introduced in the European Union to regulate hazardous industries. So, it established strict safety protocols for chemical plants and handling dangerous substances. So, stronger regulatory oversight for hazardous industries. So, industries handling toxic and explosive chemicals are now subject to regular safety audits. Companies must assess risk and prepare detailed safety reports. Implementation of early warning and emergency response systems. So, mandatory gas detection and alarm systems were enforced. Emergency planning became a legal requirement, ensuring faster response to chemical leaks. Okay. So I think you would have understood the case study of Seveso chemical disaster. Next we are moving to next slide, that is management of change. So uncontrolled process changes can lead to catastrophic failures. Uncontrolled processes changes can lead to catastrophic failures. So case study we are taking Piper Alpha disaster 1988. Okay. Piper Alpha disaster case study explanation we are going to discuss. So, the incident happened on July 6, 1988, location Piper Alpha, offshore oil platform, North Sea. So, what happened? A gas leak caused a massive explosion on the platform. So, the resulting fire spread rapidly, destroying the structure. 167 workers were killed, making it the deadliest offshore oil disaster. What are the causes of the disaster? Poor communication of maintenance changes. A pressure safety valve was removed for maintenance, but workers were not informed. When the system was restarted, gas leaked from the open pipe, leading to ignition. And failure to follow MOC procedures, the temporary maintenance procedures were not documented properly. Workers on the night shift were unaware of the massive safety valves. Inadequate emergency response measures, no proper firewalls or safety barriers to contain the fire. The emergency response training was insufficient, leading to confusion. The platform's fire protection system was deactivated, preventing fire suppression. So, what are the lessons we have learned? Strict MOC management of change policies for process modifications. So, every maintenance change must be documented and communicated properly. Approval system should be in place before restarting operations, right? Effective communication during shift handovers. All workers must be informed of ongoing maintenance and risk. Detailed logbooks and handover meetings should be mandatory, right? So implementation of better offshore safety regulations. The Cullen report, that is 1990, introduced stricter offshore safety laws. So independent safety inspections became mandatory for oil platforms. Automated emergency shutdown systems were implemented, right? So impact of on offshore safety. The disaster led to major reforms in offshore industry safety, right? So I can conclude that the Piper Alpha disaster showed how poor change management and the communication failures can lead to catastrophic loss of life, right? So we have to have a good maintenance. Okay. Next, moving to next case study, that is worker engagement in process safety. So frontline workers are essential in identifying and mitigating safety risk. So we'll take case study of BP Texas City Refinery explosion 2005. Okay, so what happened actually, the incident? So this incident has happened. So this incident has happened on March 23rd, 2005. So location is BP Texas City Refinery, Texas, USA. So what has actually happened? Incident. So a hydrocarbon vapor cloud explosion occurred due to the overfilling of a distillation tower. So 15 workers were killed and 180 were injured. So the explosion damaged nearby buildings and caused millions in losses. So what is the causes of the disaster? Workers' concerns about safety were ignored. So employees repeatedly raised safety concerns, but management did not act. The safety culture was weak with a lack of accountability for hazards and poor maintenance and safety culture. So poor maintenance and safety culture, right? So the distillation tower safety systems were outdated. There was no proper hazard identification for abnormal operations and faulty alarms and control instruments. The alarm system failed, preventing early warnings of overfilling. The level indicators were inaccurate, leading to excess hydrocarbon accumulation. Right. So, what are the lessons we have learned? Strengthening worker participation in safety programs. Workers should be actively involved in their safety discussions. Employee safety concerns must be taken seriously by management. Regular training and awareness sessions. Frequent safety drills should be conducted. Workers should be trained to identify and respond to hazards. Implementing robust incident reporting mechanism, encouraging near miss reporting helps prevent future accidents. So anonymous reporting systems can help workers voice safety concerns without fear, right? So what is the conclusion we can make from BP Texas City Refinery explosion? So the BP Texas City disaster showed how ignoring worker concerns and poor maintenance can lead to a catastrophic explosions, right? Okay, next we are moving to next that is case study, competence in process safety. So a competent workforce is crucial for process safety management. So we'll take one case study, that is Union Carbide Institute plant explosion 1991. So what is the incident actually happened? Okay. So it is happened on August 11, 1991. Union Carbide Pesticide Plant Institute, West Virginia, USA. What happened? A pesticide production unit. This is actually, it is recently happened, right? 1991 means not so long, so right. So what happened? A pesticide production unit exploded due to operator error and equipment failure. No fatalities, but several injuries and significant damage occurred. A large toxic gas release raised concerns over emergency preparedness. What is the causes of the disaster? Inadequate operator training. So workers were not properly trained on handling hazardous chemicals. Lack of awareness about critical safety systems and shutdown procedures. Poor understandings of process hazards. So the chemical reaction was not properly maintained. Operators failed to recognize early warning signs of a dangerous buildup. So lack of emergency response drills. So no regular emergency response drills were conducted. Delayed evacuation and response actions worsened the situation, right? So what lessons we can learn from this? Comprehensive training program should be mandatory for all employees. Workers must understand chemical reactions and emergency shutdown procedures. So competency based certification for handling hazardous materials. So employees handling dangerous chemicals should have competency based certifications. Employees handling dangerous chemicals should have competency based certifications. Regular test and assessment should be conducted, and regular safety drills and audits, right? Conducting mock emergency drills ensures workers are prepared for real incidents. Regular audits of equipment and safety procedures are help prevent failures. So what is the conclusion we can make out of this? The Union Carbide Institute explosion showed how poor training and lack of emergency drills can lead to serious industrial accidents, right? Okay. So next we are moving to other case study, that is safety culture and incident prevention. Okay. A strong safety culture reduces the likelihood of process safety failures. So what is the case study we are going to discuss? Formosa Plastics propylene explosion. Okay, 2005. It is also very recently happened. Okay. So incident summary where it has happened. So it has happened on April 23rd, 2005. Location for Formosa Plastics, Point Comfort, Texas, USA. What happened? Incident. What happened? A propylene gas leak ignited, causing a massive explosion and fire in the plastic plants. The blast injured several workers and caused significant damage. The fire burned for hours, affecting production and leading to financial losses. What is the causes of disaster? Lack of process hazard analysis. The risk of gas leaks was not properly assessed. No detailed study of potential failures point in piping systems. Inadequate monitoring of piping system. So pipelines were not inspected regularly, allowing undetected propane gas leaks. Corrosion and equipment wear were overlooked. Failures to detect early warning signs. So pressure fluctuations. Failures to detect early warning signs. Pressure fluctuations and gas leaks were not properly investigated. Operators missed warning signs of an impending failure. Right. So what lessons we have learned? Regular process safety assessment. So plants must conduct routine hazard assessments to identify risk. So plant must conduct routine hazard assessment to identify risk. Regular safety audits can prevent similar incidents, right? Use of automated leak detection system. Gas sensors and automated alarms should be installed to detect leaks early. Real-time monitoring can prevent quick alerts to prevent escalation. So what is the conclusion we can make from the Formosa plastic explosion? So it highlights the critical need for a early hazard detection and a strong safety culture. Okay, fine. So which means regular hazard assessment, ensure early risk identification, automated monitor system, improve leak detection and response, safety culture and proactive interventions. Automated monitoring systems improve leak detection and response. Safety culture and proactive interventions prevent catastrophic failures, right? So next we are moving to next case study, that is inherently safer design in process industry, right? So inherently safer design in process industries. So applying ISD principle minimizes risk at the source. So we are going to discuss about T2 laboratory explosion. What is T2? Is anyone aware of this T2 laboratory explosions? 2007. It happened on 2007. Anyone? Okay, we discuss about it. So this not actually T2. It is TL laboratories. Okay. So, sorry, it is a correction. It is a TL laboratories. Okay. So it is happened on 2007. Fine. So what is happened? It is happened on 2007 TL laboratories. So what happened? A chemical reactor exploded due to a runaway reaction, and the explosion caused significant damage to the facility. Possible worker injuries and environmental impact. Right. right? So this T2 or TL, just wait a minute, I will check once again. Yes, this is yes, it is correct only. T2 laboratories only. Sorry, T not TL. So this T2 laboratory is actually located in Florida. Okay, this T2 laboratory located in Florida. Actually, when the incident is happened on December 19, 2007, right? So the facility experienced a catastrophic explosion and fire during the production of a gasoline additive called methyl cyclopentadienyl manganese tricarbonyl, that is MCMT. We call this as MCMT, right? So how this has happened? How this chemical reactor exploded due to a runaway reaction. So this explosion caused significant damage to the facility. So possible worker injuries and environmental impact, right? Right. So what are the causes of disaster? Poor process design with no inherent safety features. The system lacked a built-in safety mechanism to control reactions. Insufficient reaction control systems. Yes. No effective temperature, pressure, or reaction monitoring was in place. Failure to manage heat accumulation leading to an unstable reaction. Okay. Failure to conduct a proper hazard analysis. No process hazard analysis was done before scaling up the reaction. Lack of risk assessment for runaway reactions. So from this, what lessons we can learn from this? Application of inherently safer design principles. So design processes to eliminate hazards rather than control them later. Use of safer chemical process and materials. So substituting hazardous chemicals with safer alternatives. Implementing reaction kinetic studies to understand chemical behavior. So enhanced process hazard analysis. Conduct detailed hazard studies before scaling up reactions. Use process safety management system for continuous monitoring. Okay. So what I can conclude from this T2 laboratories. Again, I am confirming that it is T2 laboratories explosion demonstrate that process safety starts with the design. So design safer processes to eliminate hazard at the source. Okay, implement automated reaction control system. Conduct thorough hazard assessments, right? So this is what lesson we have learned from this. Okay. So next we are moving to last slide, that is conclusion slide. Conclusion slide. So we have discussed so far about case studies of first unit. Okay, and now we are going to discuss about the conclusion of case studies. Why we discuss all these case studies? What is the importance of these case studies? Right. That is what conclusion is. Right. Okay. So these case studies emphasize the importance of leadership training, process safety culture, regulatory compliances. Okay. So what is the leadership importance in safety? So training to ensure safety compliances, process safety culture to prevent disasters, regulatory compliances to follow safety standards. So learning from this past incidents can help industries. So learning from these incidents can help industries improve process safety management frameworks and reduces risk, right? Reduces risk, right? Okay, fine students. That's all about today class. We have discussed different case studies with respect to Unit 1. And if you have any, go through the slides of case studies. If you have any doubt, and ask me online or offline. Okay. Thank you all for listening. We will meet next class. Thank you.